Hello everyone, welcome to lesson 16 of our Golang course. In this coding session, we are going to put everything that we learned about arrays in the previous lesson into practice with some code. So let's get started. I've again written down all the things that we are going to cover. First, we will cover different ways of array declaration, followed by the len function that is used to calculate the length of the array, accessing array elements by their index, and trying to access array elements outside their range. We'll see what happens, and two-dimensional arrays. So let's get started. First, we will look at array declaration in the most basic form. Here I'm saying var a is of type int array of size 5. If you remember correctly from our lesson, this will be a 5-element array and every element will be initialized to the 0 value of int, which is 0. So let's try and print this value and see what happens. fmt println a. So I'm going to run the program with go run main.go and see what happens. Go run main.go. As you can see, there are 5 elements in the array and they are all initialized to 0. Next we have is array declaration with elements. So initializing the elements in the array in our declaration. I'm just going to comment this out. As you can see, here we are saying var a is equal to an integer array of size 5 and the elements should be 1, 2, 3, 4, 5. Now I can also do a assignment shorthand like this, and that should be fine since we are initializing every element in the array. So let's try and print this array fmt println a. Go run main.go and you can see I have 1, 2, 3, 4, 5 printed. Next, we look at the sparse array declaration. If you remember from the lesson correctly, sparse array is where we initialize some of the indexes or some of the elements and leave all the other ones to be the 0 value for the type. So if you remember from the lesson correctly, this is a sparse array declaration where I am saying a is colon equal to an int array of size 5. First element or the 0 index element should be 5. Second index element should be 10 followed by a 50. So we should expect all the other values that we haven't specified here to be 0. So I can do fmt println and then run our program go run main.go. You can see the 0 index element is 5, then 0, then 10, 50, and then 0 again. So that's the sparse array declaration. Now let us see the last one, which is the implicit length declaration. So I can do a colon equal to 3 dots or ellipses and then whatever values I want here. I can say 3, 4, 1, 2. I'm just going to comment this out and do fmt println a. So here what I don't need to do is that I don't need to specify the length of the array. I can just do ellipses and go will implicitly get the length of the array. So let's run the program to see what we get in the output. Go run main.go and you can see 3, 4, 1, 2 printed to the console. Now as I told you in the lecture, we can use the len function to calculate the length of the array. Inside the println statement, I'm going to use len function. Len a. So as we said with ellipses, the array length is implicit. So we should see 4 printed to the console when we do len a. Go run main.go and here we have it 4 printed to the console, which is the length of the array. So that's basically how you get the length of the array with the len function. So let's now look at accessing array elements. So to access the array elements, we need to use their index in the array. As we talked about in the lecture, the first index is 0. And the next one 1, 2, 3, 4. So we have an array of size 4. So the indexes will be 0, 1, 2, 3. The first index is always 0 and the last index will be length of the array minus 1. I'm just going to comment this out. You can store it in a different variable like this a. If I want to access the first element, I can say 0 and I can do fmt println b. That should print 3 to the console. So I can run the program and say go run main.go. You can see 3 printed to the console. And to access the last element, which should be length, that is 4 minus 1 or 3. So the index 3 should be the last element. Let's run our program and verify that. You see the last element printed. What happens if I try to access an element that's out of bound or out of the range of the array? So that could be minus 1 since the first element is always placed at the 0 index, so there is no negative index in an array. If I run the program, as you can see, it informs us that the index can never be negative. What if I try to do an index that's greater than the last index? or length minus 1. I can do 5. What happens if I run this program? So you can see index 5 is out of bounds. It says the length of the array is 4. So the indices you can access are 0, 1, 2, 3. This notation is very common in Go. This means it's inclusive for the first index and exclusive of the last. What that means is the array size is 0, 1, 2, 3 or up to 4 but not including 4. Cool. So I'm just going to revert it back to maybe 2 this time and then we can print it. You can see index 2 element, that is 1, is printed. 0, 1, 2. We can also do this directly instead of creating a variable. So I can do a2 go run main.go and you will see 1 printed to the console. So I'm just going to comment everything out that we have done here and then we will move on towards creating a two-dimensional array. So a two-dimensional array can be created in Go like this. We need to specify the size, otherwise if we don't specify the size, A is treated as slice, which we will cover in the next lesson. And you need to remember slices are different from arrays. So I can say 2, 2, then I can initialize inside two arrays of size 2. So 1, 2, 3 and 4. So here I am creating a two-dimensional array of size 2 by 2 and the first row is 1, 2, the next one is 3, 4. So what happens if I try to add another element? You will see the ID will complain because it can see the size is 2 and we are trying to exceed that size. Now let's print this and see what we get. You can see there are two arrays inside the bigger array and they're printed. So that's basically how you can create a two-dimensional array. That's it for the lesson. In this lesson, first we covered array declarations. First one was the basic form where we say array A is of length 5 and type int, where every element is initialized to the 0 value for the int, which is 0. Next, we said array A is of type int again and length 5, and we initialized every element in the array ourselves. Next, we have a sparse array where we only initialized some indices in the array. And the last one was implicit length declaration, where we use ellipses inside the square brackets to tell Go that it should figure out the length of the array by itself. And the elements were 3, 4, 1, 2. It's important to know that once declared, the length of the array cannot be changed. So if I try to add any values here or say, for example, let's comment this out. I'm going to comment this out and let's say if I wanted to say A1 is equal to 10 now. So if I print the array A, we should see that instead of 4, we have replaced the value with 10. So if I run go run main.go, there's another stray fmt println. So I'm going to comment this out and run the program again. Go run main.go. You can see the element at index 1 has been replaced by 10. This is how you can also manipulate the array elements. Once declare, the length doesn't change, but you can still change the elements inside the array by again using the index of the element and then assigning a value. So if I try to do A5, it will complain about index being out of bounds. Next, we looked at the length function, which gives you the length of an array. It's simple. You just pass the array and you will get the length of the array. And last, we looked at multidimensional array, where we created an array which had a size of 2 by 2, and inside that we initialized two separate arrays. That's it for the lesson again. You can practice it and try to see how to use different declaration forms for array and then assessing and updating the elements in the array. Also try to play with multidimensional array. Again, arrays are not widely used in Go directly. Instead, we prefer to use slices, which we will cover in the next lesson. Happy coding. See you in the next lesson.